Okay guys, here's the intro for this section of questions on matrix operations. We're going to go on a little route map here. We're going to go to transpose first in the first few questions. Then we're going to go on to working out determinants of 2x2s and 3x3s. I want to explain what they are. Then from determinants we're going to find the cofactor matrix of just 3x3s. That will take us to the adjoint of a matrix A. And then from adjoint we can write down the inverse. The hardest thing I think is the cofactor. The determinant is probably the second hardest thing there, but we're on a route to get the inverse. Rather than have a long introduction here, what I'm going to do is intersperse the questions on the different topics with a little intros along the playlist. Yeah. So here I'm just going to do transpose for the first few questions. So what is a transpose and how do you get it? Well, the transpose basically you just flip it around. So you exchange the rows for columns or the columns to rows. So you can see an example here of a 3x2 matrix. If you want to take the transpose, you write T to denote the transpose of this matrix. And if we do it as though we're changing the rows to columns, there's the columns to rows. There's the first column. We peel that off the page, turn it over and put it along the first row. See it? And then the second column, we peel that off the page and the second column becomes the second row. Right? And if we decide we think we prefer to do it by rows rather than columns, let's take the row. The first row becomes the first column. Second row becomes the second column. Yeah, and the 6 and 1, the third row becomes the 6 and 1, third column. There it is there. Identical results, see it? So it's up to you. It's a preference. Sometimes you may flip it around one way. Sometimes you may choose to flip it around the other way. Either ways, you're going to get the same result. If you go from rows to columns or columns to rows, when you turn it around or flip it around, so to speak, you're going to end up with the same matrix. So that's transpose then, and there's a fair few examples in the first section. Okay, I'll catch you in a bit then in the next little intro in this section. Cheers!